10.2.9, and originally I think Mayra asked a question about this one, and then I thought, well, why not make a recording for everybody, because this is a great example, and I can show you both the Z approach, which they call the classical approach, and how to test using the p-value. So first of all, we have H naught, which is our null hypothesis, that p equals 0.5, and we have the alternative hypothesis, H sub 1, that p is less than 0.5. And I'm sorry if you can hear the planes in the background. I live right near the airport, and it's constant, so I apologize. Then we have that n equals 150, our x is 66, and alpha is 0.10. So next we have to perform the test using the classical approach. So that means that we're testing with z. So let's just write this out. So again, H naught, C, is going to be 0.5. H sub 1, which is our alternative hypothesis. Sometimes you'll see it written as H sub A as well. So if you see another video or go look at another textbook and it says HA, that's just the alternative hypothesis as well. And it's that P is, oops, I'm sorry, I shouldn't write that like that. That was bad. I will write that as P equals 0.5. Otherwise, you don't really know what you're talking about, whether you're talking about a mean or proportion. So that was a bad way to write it. So let's just fix that. Okay, that P is less than 0.5. Okay, so those are our hypothesis setup, our hypotheses. So because we have that P is less than 0.5 is the alternative hypothesis, that means we're dealing with a left-tailed test. So just in case you weren't sure which tail to use, less than, which is this guy, so this is less than, is a left-tailed test. So if you look at your normal distribution, it would look something like this. We'd have this left-tailed rejection region, okay? If you have a greater than symbol, so this is greater than, then we have the distribution that looks like this, and your rejection region looks like that. If you have the not equal to symbol, then you have your two-tailed test, and we split up that alpha, which is the area under the curve, into two different sides, the left tail and the right tail. So it would be more like alpha over 2 for each side. Okay, so in this case we're using left-tailed, so that's going to be less than. So I'm just going to cut these guys because we don't need them. And cut. Okay, and we're just going to use that less than for the left-tailed test. Okay, so the first thing that we have to do is calculate our p-hat. So we also have here that n is 150, so that means our whole sample size is 150. X happens to be 66, so they don't give us the context of the problem here, but we know whatever they're testing, 66 of the units displayed this event for whatever reason. And then alpha is 0.10. So they're just giving us the numbers. So to find our p-hat, we're going to do x over n. So that's going to get us 66 over 150, which I just go ahead and I use my calculator over here because I can't find my other one for some reason. One of my children probably has it somewhere. And we do 66 divided by 150. And I'm getting 0.44. So I'm going to write that down, 0.44. So there's my p-hat. Now to do the classical approach, the next thing we're going to do is calculate our test statistic, z-naught. So z-naught is going to be our test statistic. And the way that you calculate that is we're going to do p-hat. Oops, I don't know why I put an equal sign. Should be minus p initial over your square root of p initial times 1 minus p initial all over n. And this formula is in the text. Honestly, the only reason I have things memorized is because I've done them so often. But always go and look for your formula. I would, if I were you guys, as I go through especially the upcoming chapters, just make a nice little sheet for yourself where you can access all your formulas really easily. And I think even in the appendix of the text, there's a great page that has like all the formulas for each chapter. And I'll look into that and see if I can post it for you. So here's what it's going to look like. We're going to have 0.44 minus 0.5. And then over the square root of 0.5 times 1 minus 0.5, which is still 0.5. Plain all over 150. Okay, so let me just type that into my calculator here. And so I'm going to put parentheses around my numerator. So 0.44 minus 0.5, close them, divided by the square root of 0.5 times, I'm just going to do the subtraction here, 0.5. You could always do your parentheses if you needed to. And we're going to divide that by 150. Okay, and that gets me approximately negative 1.47. I'm going to round. So I'm going to just move this up here. So that's going to equal negative 1.47. So this is my test statistic Z naught. So let me just put a different color. We'll like box that in here with red. So this is my Z naught. Okay, so if I'm going to go ahead and do the classical method here, what I need to find, I'm going to just go back to my little picture here, is what's this Z-score when it comes to an alpha of 0.10. So alpha 0.10 means that the area here is 0.10 in the curve. So the way that we do that, really easy on StatCrunch. So if you go to StatCrunch, I believe I have it already up here. Okay, the way that I got to that little calculator is you go to Stat, Calculators, and then down to Normal, because we are using the Z distribution here. And because I know the area, I'm going to plug that in over here. So this is going to give me that little red region. So I want an area of 0.10. And it tells me that that value is going to be negative 1.28. So this Z-score here is negative 1.28. Now, the reason this is called a rejection region is because, hold on, if my test statistic falls in the rejection region, I reject H naught. If it's not in the rejection region, then I fail to reject H naught. I often kind of refer to hypothesis testing as kind of the results of even a legal jury type of decision where you have guilty and you have not guilty. If you find a person guilty, well, do we ever really know if they were guilty? No, but the jury of their peers said that they were guilty. If we say not guilty, do we really know if they're completely innocent? No. So this, again, hypothesis testing is there enough evidence to show that we can either reject H naught or fail to reject H naught? So is negative 1.47 to the left, or in this rejection region here, of negative 1.28, and that is true. So we'd say we would reject H naught. So here we would say reject, ooh, that's a terrible R. We would say here, reject H naught. Okay? Okay, now how will we change that and make it a p-test? Well, we actually have everything we need here to create a p-test. So for the p-test, you also still need to know your test statistic Z naught, which we've already calculated. Now we're going to do the opposite here. This time, the p-value is actually the area under the curve, in this case to the left, because we're dealing with left-tailed test, of our test statistic. So it's like we're going the opposite here. In my little calculator over here, I'm going to get rid of this 0.10. And I'm going to say, well, what's the area to the left? See how it says less than here? I'm going to keep it as less than because it's a left-tailed test of negative 1.47. Now, if this had been a right-tailed test, I would change this symbol to greater than. If it were a two-tailed test, we would have to go ahead and just multiply whatever area we get by 2. Okay, so in this case, I'm going to go ahead and say, okay, compute that area to the left. And the area to the left is 0.0707. And I think they wanted us to round to 4 decimal places, so I'd call it 0.0708. So because my p-value, I'm looking here, so here my p is 0.0708. Now, the way that you do the p-test is you're comparing p to alpha, and in this case, alpha was 0.10. And the p-test always goes like this. It doesn't really matter if it's a left-tailed test, a right-tailed test, or a two-tailed test. It's a little rhyme here. If the p is low, you reject the ho. So meaning you reject H naught, right? So if p is lower than alpha, you're going to reject H naught. So considering that p here, 0.0708, is less than 0.10, we reject H0, and we still get the same exact result as if we had done a z-test. So if the P is low, reject the HO. Okay, so let me know if you need anything else here. That runs you through 2 examples. Just so you know, if you go to the text, there's, I think it's on page, let me see here. Page 489 is awesome because it shows you the classical approach and the p-value approach for a couple of different examples. So I think it has a left-tailed test. The next one is a two-tailed test on the next page. So those are some great, here, classical approach and p-value approach, some great examples for you to follow as you're doing those problems.